All right, quotient rule. When you have two functions that are being divided, as you see here, you got a function on top and a function on the bottom. In order to find that derivative, you have to use quotient rule. And quotient rule, again, is your low function times d high, derivative of the high function. Whereas we're saying this is high and this is low, minus your low, or sorry, high d low. All over the low function squared. So that's kind of the little saying that you can use to do these. Let's apply it to a problem here. So we want to use quotient rule to find this derivative. So when we're doing it here, we want to go low, which is 1 plus x squared. D high, derivative of e to the x is e to the x, minus high, so e to the x again, below, what's the derivative of the bottom? Well, derivative of 1 is 0. It's a constant. Derivative of x squared is 2x all over our low function squared. So that's the derivative. If you can simplify. Here, I don't know that there's a ton we can do. One thing you may see on AP tests on a problem like this, though, is see how they both have an e to the x, the two terms on top. We could factor that out. And if you factor that out, what would be left in the first one would be this 1 plus x squared minus what's left if you factor e to the x on the second term is 2x. Once we do that, you want to see, well, can we factor this anymore? I'm going to rewrite that top a little bit in descending order because that's usually how we see it. So x squared minus 2x plus 1. So does that factor at all? It actually does. That would factor into x minus 1 times another x minus 1. And so one way you may see this if it was like a multiple choice question on the test is that they would have the answer written like this, or they might even go probably one step farther. Since this is x minus 1 times another x minus 1, we could write it as x minus 1 squared. So that would probably be the way they'd have it on a multiple choice question on the exam. Let's try one more here. We had looked at some of those trig derivatives earlier. One of them was that derivative cotangent is negative cosecant squared. Well, how did they come up with that or get that? If these are ones you don't remember on the test, you have to know the sine and cosine one. You should be able to get all the other ones from the sine cosine one. And the way we do that is how we would show this one. Cotangent is the same as cosine over sine. So now if we apply the quotient rule to this, we should come up with that this somehow equals negative cosecant squared. So let's do that here. If we apply the quotient rule, we got low d high, derivative of cosine is negative sine, minus high d low, derivative of sine is cosine, all over our low function squared. Well, let's simplify this. Sine times sine is going to be sine squared, and it's negative there, minus cosine times cosine is cosine squared, and on the bottom we have a sine squared. To get it to equal that negative cosecant here, it looks like on the top, since both are negative, let's factor a negative out of that. So now it'd be sine squared plus cosine squared, and that you should recognize. That's one of those Pythagorean identity that we talked about before. Sine squared plus cosine squared equals 1. So now we got negative 1 over sine squared, and we know 1 over sine is the same as cosecant, so this would be the same as negative cosecant squared, and that is the derivative that they had listed before and they wanted us to show. So that's where those other ones come from. If you forget tangent, cotangent, secant or cosecant derivatives, use quotient rule to get them.